Welcome to another session of astronomy. In today's session, we're going to talk about precession. We have already encountered the idea that the Earth's axis of rotation is at 23.5 degrees relative to the orientation of the solar system. So if you take the Sun and the planets, that disk formed by the common plane of motion around which all of the planets turn, the Earth's axis isn't exactly at right angles to that, is at 23.5 degrees. A consequence, no doubt, of the giant impactor that created the Moon 4.5 billion years ago. Now this axial tilt is what produces Earth's seasons. With the Earth's axis tilted like this, at one point in the year, the northern hemisphere will be pointing more squarely at the Sun, and 6 months later, the northern hemisphere will not be, the southern hemisphere will. And so this means that the sunlight lands more directly down on the summer hemisphere and obliquely on the winter hemisphere, causing the difference in temperature. Now, did you know that this axis itself isn't fixed? Well, this is this concept of precession. At this point in time, if we looked straight up from the North Pole, above our heads, what would be at the zenith in the sky? Well, it would be the pole star. We'd be looking straight out at a star that we call the pole star because it's right above the pole. At every other point in the northern hemisphere, looking in the direction of the pole star enables us to see directly north. We can see where the north is. Now, the pole star has very special meaning in the night sky because around the pole star, the entire sky appears to rotate as the Earth turns on its axis underneath. The pole star never sets. It's always in our sky, though sometimes you can't see it because it's daytime. Those stars that go around it that never set are called the circumpolar stars. Now, the pole star sits at the end of the axis of the Earth in the northern hemisphere, totally by chance. We could be pointing at any star, but a particularly bright star appears to be at that position right now. But it hasn't always been so. Because the gravitational pull of the Sun and the Moon on Earth's equatorial bulge has slowly been causing the Earth to gyrate. In fact, the axis hasn't stayed true. Over thousands of years, the axis has actually gone through a complete rotation. At some point, it would be pointing over here, and then a good number of 13 years later, it would be pointing over there when it's on that same side. Now, this is called precession. Now, you've got to be careful how you spell the word precession. It's P-R-E-C-E-S-S-I-O-N. When you write it into lots of word processors, it will try to change it into procession, like you're processing, whatever. You get the spelling right. So basically, this is it. It's a 26,000 year cycle. That means that what is above our North Pole right now slowly changes year after year after year. Now, it was first noticed really early on by Hipparchus, the ancient Greek astronomer, when he was mapping the sky in 130 BC. Now, the actual motion of what is immediately above our North Pole, it changes as time goes on. You can see right now that right above our heads, near the sea of Pardalis in that picture there, there's Polaris. It's the brightest star in Ursa Minor, the little bear, as we recognize it. But if we rewind the clock, then you can actually see that the pole, near where it says AD1 on the right-hand side, at the time of Hipparchus, that the stars that were in the north and directly above the North Pole were actually stars in Pardalis, the giraffe. And if we go back further in time, we see that the pole star could have been one of the stars in Draco, the dragon, or Bootes, the herdsman, or Hercules, the hero. In the future, we're going to have the pole drift through Cepheus and onwards and onwards. Now that means, if this is true, that if we looked at a star chart from long enough ago, it wouldn't have the pole star right at the very center of the star chart. It would have something else. And indeed it does. So this is a map of the constellation pointing out a particular important time in someone's life, perhaps a birth diagram. Now, it looks a bit unfamiliar to us because the constellations have all somewhat changed. This is what the ancient Egyptians saw in the night sky. Some things are the same. You can see there's a Taurus-like animal, and there's a Scorpio, the scorpion, and a lion. But the constellations around the middle are a little bit different to us. You can see there's the dragon, which kind of looks like it's standing on its hind legs, a big yellow creature holding a knife. If you take your eyes on that, that's called the dragon, which we think is Draco the dragon, which is around the North Pole. And looking at the position of that, we can see the dragon, the knife in the dragon's hand is actually a mooring post. And we think that the very bright star Polaris is the handle of the mooring post. But if you look at what is the very center of the diagram, what was the center of the night sky or the celestial sphere, it's that little red animal, which is called the petit ours, right? It's like a little tiny red animal. We can see that the pole has actually moved between the carving of this constellation map and the present day. Now, Egyptologists actually found this really interesting to do because they found some constellations that were not only thousands of years old. We could say that basically this map of the constellations comes from more thousand years ago than at that time they currently believed the age of the universe. What they had done is they'd taken a literal biblical understanding of how old the universe was by adding up all of the ages of the people in the Bible. But these star charts were older than that, and they were depicting real events. So the conclusions were either all of these star charts were wrong, or the universe was older than it literally quoted in the Bible.